Hi everyone, welcome to the stream. So, today we're going to continue working on the refactor we started doing. So yesterday, we realized that we ended up running into this like weird issue with the effect system. And so today we kind of get to address that. And what I mean by that is, let me move this over here real quick. Okay. Cool. So what I mean by that is we found out all the effects, like the add effect function returns an effect reference. At least it did. We changed this very, very recently. So this right here means that when... Excuse me. I'm reorganizing my windows as I speak, which is kind of... Okay. I think I got it all figured out. Sorry about that. Whee! Alright. So yes, what ended up happening was add effect returned a reference pointer. So that got me thinking, okay, well, why are we returning a reference pointer, right? That's a little strange. At least I want to believe it's a little strange, because what ended up happening was, let's say you make a reference, right, to this effect, and then you do something with it. Well, let's say later on another effect gets added. It's pretty common that when you're creating these effects, you might create multiple in a row, right? Like, you might spawn like 100 particles at once. And then let's say you did spawn those 100 particles. Now, you end up in this scenario where this vector probably expanded, right? So that reference you got earlier is probably stale. Unless you did something immediately after the return of that function before the next loop, if you like want to store it, it might not necessarily be valid on the next game tick. So that's actually the issue we were running into when looking at trying to implement this in lightning bolt emitter. What we want to accomplish is the lightning effects that come from this ability, we want to actually capture each one. We want to say, okay, we're going to store all of you in a list. But if we store them all in a list, even as reference wrappers, they could get invalidated the next time we look at them. Plus, we don't actually know if they are still alive or not. The data could be used for something else in the future, and we wouldn't know the better. So that was the first issue. The second issue is that we need to update the positions of all these. So we either like reference the lightning bolt emitter itself, but then it's like, it's a double-sided problem. What if the lightning bolt emitter dies before the effect dies? It can go either way. The effect lasts for about a second, but if the lifetime of the lightning bolt emitter is less than a second long, then the effect is going to try to grab data that will no longer exist when the lightning bolt emitter dies. In other words, we run into this scenario of undetermined lifetimes. So one way to solve this is to transform all of these effects. Well, instead of returning an effect reference for add effect, let's return a weak pointer. So if we convert all these used to be unique pointers, by the way. The container owned the pointers, and by design, they still will. It's just we're going to make a shared pointer out of it, which means if we return a weak pointer, then we can reference that weak pointer later and see if it's still alive. It allows us to see if that shared pointer has died or not. And the rule of thumb is, as long as only one container or one location has the base shared pointer, you're good to go. As long as you use weak pointer everywhere else, then you pretty much are guaranteed that this is the, what do you call it? This is like the authoritative source for this effect, and when it dies, all references to that effect are also considered obsolete. The one thing that can really mess you up when you use these shared pointers is if you start storing the shared pointers in other locations. Don't ever store shared pointers in more than one location. You'll just end up with them staying alive and wondering why your code is suddenly not doing what it's supposed to do. It's like, oh, this was supposed to be dead, but the data is still existing and alive. And so your code won't function the way you would expect. So that's the thing we have to make sure of, is we have an authoritative source, these containers, for this shared pointer, and then everything else references them by weak pointers. So that's what we're doing today. This actually breaks a lot of code because a lot of code assumes that these were references before, so we're going to be refactoring that today. It will take a little bit of time, but this refactor will be for the future, a future benefit. So first, I'm going to go up here to the other version of add effect, another overload, and we're going to change foreground wrapper and background wrapper from being reference wrappers to just being standard weak pointers, because that's what we want them to return, both the foreground and background weak pointer. And you can see here we used to use unique pointer, so now we're going to use a shared pointer. And we used to use standard move. So yesterday I was considering using standard move on the shared pointer as well, but then I'm like, well, what we really want is to just return a weak pointer from whatever we emplace back into there. So we accept an effect instead of a shared pointer as the argument, and then we create the shared pointer at this moment. This way we're avoiding like passing around other pointers and assuming they're still active. Like, it used to be that this was a standard unique pointer, and when the parameter was standard unique pointer, we made the pointer somewhere else, and then it got moved, so it became an invalidated pointer. Unless you remember this, a little detail, you might assume the pointer is still valid, at least for one more tick. But that wouldn't make sense, right? Because obviously if we're adding effect, the game's going to obtain that pointer. So yeah, there's a lot of like little system design issues that we had to think about yesterday when discovering this, and then making an executive decision to finally choose to do this in the end. So this is kind of a re-architecture of how we're designing the effect pointer system. So we're changing these two parameters. We're not even going to use shared pointers here because, like I just discussed, we realized that if we're going to pass in pointers and just move them to another container, why not just create the effects in place, right? So we will accept, and I was thinking about just accepting our values here, and it's kind of a weird decision, but the reason why is because we don't actually want this effect to be used somewhere else. For example, let's say we make our effect like outside of the add effect function. Like, let me go to where I would make this, right? So let's say instead of like defining the effect in here, I defined it outside. I'm like, effect, new effect, right? And I just made this on the spot in here. Then I said, okay, now I'm going to copy this, or I'm going to send this into this function. Now it's going to be added to a container, and a weak pointer to it is going to be returned. But the issue now is that I can still reference this new effect I made, and it's not going to adjust the effect the game actually is using. So by only accepting our values as parameters in here, we're essentially saying you have to create it right in here on the spot. You can't create it outside and store it anywhere. So that's kind of what I want to do in this scenario. Just an extra little trick on top of everything else we're going to do to really like refactor and fix this stuff. So now we're going in here, and we're going to call add effect for both of these. That's going to pass these R values into here, which are then going to be emplaced back in there. And we looked at it yesterday. The copy constructors were taken care of. Also, this parameter is called foreground, which is a little misleading. Like, all of these are considered the effect, right? So to call it foreground, I think I just copy pasted it kind of lazily, and that's probably why that exists as it does. Okay, and then finally, add effect returns these weak pointers, so really we're just plugging these in both here and here. The true indicates it's a background effect, so really those are in reverse. The foreground is going to go here, and the background is going to be returned there. They're returned in a pair. So now we're going to adjust these usings to say they're no longer reference wrappers, they are now weak pointers. Okay. So that should take care of that. So far, so good. And now we're back over here. So, obviously these don't exist. We just changed everything about them. So we're gonna have to make that first. I'm also gonna condense these, as this is kind of old formatting. I use a new format when I write this particular code block now. So I'm gonna use that formatting instead while we're here. And let's go ahead and change the declarations of these functions now to match all the modifications we've made so far. So let's find add effect, and let's just paste in this new one. And by default, the background parameter is set to false. And then for the other one, again, we're accepting only our values. So that's what we're going to do there. So far, so good. Momonga! Hi there, Plasticky. Welcome. Yeah, Momonga is here today. Alright. So yeah, looks like everything is settled over here. Now, obviously, we've changed a lot here, so other things are going to happen now. Stop stealing my plushies. Stop putting your plushies in my house. No, I keep doing that. I love your plushies. Don't tell them, though. Alright, I'm seeing no... Oh, I do see some errors up there, so let's go take a look at those. We'll just start going through until everything compiles again, right? That's pretty much where we're at. So up here, there's probably, like, some lists that store all the effects, yeah. So now, these are going to be a little different. They no longer return unique pointers. They're going to return shared pointers. Now, because they are shared pointers, we really aren't going to return, like... I mean, I guess we could return const refs to it, but in reality, they're going to be copied over into the container as shared pointers, so I guess that's fine. So that changes that, and then as we change everything, you know, everything propagates, and we're going to have to deal with more stuff, of course, so let's just get into it. So these were coded as unique pointers before, they are now shared pointers. Now we can see here that we were using a for loop before. We were actually like doing some iterator stuff as well. So that's kind of interesting, right? Let me see if we can change or update this just a little bit. Let's see, because before we were... Yeah, this is interesting. We're just going from begin to end in the list. I wonder why we used this format and not just this very, like, the very normal, format of, like, for auto, element in list. Like, why did we choose this option? That's what I'm curious about, right? It's kind of weird. Let's change this to be standard ranges for each. Like, we might as well update things a little bit while we're in here and refactoring everything to be a little bit better. So we're going to be going through standard ranges for each on the emitter list, and the function is going to be for objects of type... excuse me. In this case, they are unique pointers to iEmitter instances. Const standard unique pointer. What is it called? iEmitter? Yeah. iEmitter reference to an emitter. And then we're going to run some code for each of those. So again, we don't need all this like fancy stuff. We have direct access to it, the unique pointer. So why not just call emitter update right there and then pass in the lambda felapse time. It should really be that simple, right? Yeah, I don't really think we had to make it any more complicated than this. I'm not sure why we chose the other syntax, really. To me, this makes more sense. Like, I like this syntax a little bit better. And these are now shared pointer effects. So we have eUpdate, or it's not an emitter, this is the effect update. Like, this is probably really old code, and so I probably wrote it this way a long time ago, and now I want to write it differently as I see fit, right? So yeah, we do something like that, and that's actually the exact same code. Then let's go down here and work on some more. Again, all this refactoring to be done. These are no longer weak pointers, they are shared pointers. This is sorting all the pointer or effects, so just sorting them so they are in, they have correct rendering order. Stuff that is higher up on the screen gets rendered below stuff that is farther down on the screen, so you get a little perspective view. Everything higher up is going to be behind the scenes of anything else. Just a nice little touch. Then here, game out effect. So we're no longer doing this, we can actually just define straight out of the gate the effect object itself along with all of its parameters, like so. And that should be the only requirement to satisfy this function. At least I think it is. Yeah, because this is an R value now, so I can actually demonstrate what I meant by this earlier. So what we're trying to avoid is you using the wrong reference and then not being able to see the result in game, right? That would be bad. That's not what we want. So instead, like, this is what we're trying to avoid here. You create, let's say you create an effect, right? Inside of here like this. And you're like, cool. Now I want to make that effect be added to the game. So I put it in here. Is it okay? So yeah, it's gonna complain now. At least it took a moment for IntelliSense to catch up. But yeah, this is not allowed. And the reason it's not allowed is because effect is... Wait, let me see. No instance of overloaded function effect matches the argument list. So argument type is an effect. Essentially, we are passing it in via copy. Now, if we pass it in via a reference, like, we actually can't, because it's expecting an R value. So it has to be something that is temporarily copied into it instead. So that was our objective with doing this, is we wanted to prevent this specifically so that later on we can't adjust to the effect and expect it to adjust it in the game, because the reference of this that we're creating is not going to match what add effect is going to spit out. So our objective is to make it so, or the way we want to use it is you pass all the parameters of a new effect instance in here as an R value, add effect creates it, and then spits out a weak pointer, and you do all of your stuff in there. So this is essentially our new effect, and then from there you do whatever you want with the effect. That is the syntax we are looking for, versus the other one I showed you where you're gonna try and edit something that doesn't exist. IntelliSense is having a very hard time keeping up with my project right now. Usually when we have to do big refactors, this always happens, so... But it's okay. That is the intention, and that was a good place to kind of show what I meant by we want to accept our values and not necessarily just any effect there, because we want that result of the game is going to tell us what reference we want. We get out of this. We're not allowed to modify. We're essentially just creating this in place. So that accomplishes what we want there. Okay, and then down here we were expecting a unique pointer, but they're now shared pointers. So go ahead and iterate through shared pointers right there. And then down here, again, wants to be a shared pointer. And then, let's see here. Like I said, IntelliSense is very behind, so I'm kind of just speeding up ahead of it. seeing the parts it did mark. So I think this file is now good. I'm just going to hit build here and we'll see where we go next, because this file should, in theory, be complete. Unless I missed something. I don't think I did. Alright, let's see here. So in adventures in Listoria.cpp, add effect illegal qualified name in member declaration. Oh. Yeah. We're not... I accidentally copy-pasted that. That's my fault. So that's probably why that didn't work out. Okay. Oh, there's another unique pointer down here, which needs to be changed to a shared pointer. Now let's see what other errors it comes up with. It's going to be plenty, I'm pretty sure. We're just kind of waiting for them to start populating. Alright, here we go. Now we're going to start changing all the calls to it to match the new thing. So, in a lot of cases, we are just creating them in place. So, we don't typically need to actually store it or anything, except for that thunder orb we're making. That's probably the first time we really need it. But yeah, I like the syntax a lot. I think it works very well and accomplishes what I want. I especially like that we get to use the R value argument to signal exactly how we want to use it. By looking at it and saying, oh, add effect wants an R value and only an R value, then it immediately tells me we have to construct it in place. It forces me to design it a certain way. I can't just modify it, do what I want, and then pass it in. Have to just make it first, get a result from it, and then modify it. It like explicitly makes sure that we can only use it in a very strict way. It looks like I typed shared pointer, which is definitely not a thing. Okay. And then we have what? I really need to expand these. Okay. Effect expecting expression instead of a type. Oh, that's just the same thing. So that's old. What else? Let's keep going, keep building these, and seeing what else we have issues with. Okay. What I should do is just hit find all references on add effect. And we just go through all of them one by one, right? Because presumably these have all changed. They're no longer compatible with the old stuff. So essentially we have to change it all. Yeah. So no more creating the pointer in place, just provide an object in place instead. And it will do the rest. So let's actually do find all references for this function and just go down the list. Until we have modified everything. Oh, I see. It's not going to detect them because the other ones use a non-existent version of the function. So it's actually being smart about it. So we're going to have to find it ourselves. Something like, we'll just look for add effect and then look for like standard make unique, and that will expose all of them. Because I know we just did all the rest that way. So let's just find all. And we should get results from that. Maybe? Find all? Okay. Here we go. So this is everything we have to change, basically. It's our to-do list. So let's go into it and start hacking away. So it'll take a little while, but again, it's for the better. Like, plus we get to just scrape through all of our old code and look at it. So that's always fun. I think I'm going to put this... put you over here, actually. That would be great. I hope everybody's doing well. Okay, cool. I just got a really important text. I was kind of waiting. I just needed an update on my medication, so I'm glad that's taken care of. That was a big thing I was worried about. Okay. But yeah, I hope everybody's doing good. Today is Thursday, so we're over the hump, right? Almost to Friday. Yes, yes. Let me just send a message real quick. Okay. Like I said, this is gonna be very chill. It's just I have to just the same thing over and over. So, yeah. Feel free to just chill and relax for a little bit because this is kind of how refactoring goes, right? If you have a very large project, you just have code everywhere. So choosing... When I have to make a decision to refactor, it's a very tough choice. I have to consider if the benefits outweigh the cost. The cost is always time, of course. We have to spend time fixing it. Potentially, we have to spend time debugging it. And we have to think about the architecture of it, because what if the refactor we make changes the behavior of it? Then we'll have more bugs to fix, right? So there's a lot of things you have to weigh before you can just consider, oh, I'm just going to refactor, in this case, a major function in my game. So when I was fighting myself, like thinking, all right, why do we want to do this? It's going to be a lot of work. Do we get any benefits out of it? What's the point? This is actually pretty critical in the sense of it avoids memory errors. I talk about a lot how I try to make sure my project is pretty dummy-proof, in the sense of we want to make it as easy for the programmer, in this case myself, to look at this in 6 to 12 months and be able to work with the codebase without having to remember every little detail. And like, the remembering isn't like, oh, what is the name of X function or Y function? Or how do I make a monster move again? Like, that's all stuff you can look at old code for, right? What I mean is we find a function like add effect. We're like, oh, cool. I remember add effect adds an effect to the game. Let me try and use it. And then I do what I said earlier and try to like create one and modify its stuff. And then in add effect, we force it to be an R value now. This means I'm no longer allowed to just do it that way. And that makes sure that in the future, if I forget this little detail of that is how we do it, the compiler is now enforcing that behavior for me. So now I don't have to remember or think about that. I just have to know that if it doesn't allow me, I did it for a reason, and then it'll jog everything in my mind to say, oh, that's why I did that. So we always want to try to make the code as dummy-proof as we can by putting in safeguards wherever we can. And we have to think about that with refactoring too, and why it's worth it sometimes. Additionally, we changed the return type to be weak pointers, so now I'm no longer throwing around references that could potentially go stale, because the last thing we need is for us to be using stale references by accident, or having to think about the stale reference part and writing code that gets around that. Like, this is all made more complex if we don't use the correct, like, data types and behavior that we want. So the less we can have to remember, the easier it becomes for us to code. It's just a philosophy I believe is very powerful and important when it comes to programming very large projects. And like I said, you have to really consider deeply, is this refactor worth my time and effort? Could it be spent elsewhere? But in my opinion, reducing the risk of any bugs in our code, especially as the complexity in our project rises to staggering heights, it's even more important than ever now that we no longer create any certain bugs, especially memory bugs, while finishing the project. Because those are kind of like, those are like the hardest things to debug. You open up your debugger, you start looking, and all of a sudden you're in some random line of code in your project, and you're like, that doesn't make sense, and then you realize your memory's corrupted, your stack's corrupted. So in my opinion, anything that can cause like huge memory errors are very much due for a refactor. And when we were looking at that yesterday, I pointed it out and I'm like, oh, I really need to refactor this. You could really screw up our memory if you're not careful with this and get a stale reference out of it. Luckily, I either remembered or managed to avoid writing any code that has utilized that so far. So I would say I'm pretty lucky here, but it could have been worse. It definitely could have been worse. Also, I'm not sure what happened with the other parenthesis there. Oh, wait. Oh, I see. It's using the true flag. That's why. Okay. So it's one argument back. Yeah, so hopefully that makes sense and why we're taking the time to do this. Like, especially when you encounter something that could create such a memory pitfall, it's due for a refactor. I need to dummy proof it so I don't make that mistake in the future. This is for my own sake. And really, that's the basis for a lot of refactors. There was another refactor I had to do probably like... it's been about a year now, maybe 2 years. I converted every single container type of my UI for this game to stop using or passing around raw pointers. Because at one point I was using raw pointers for my system. And I decided to switch to a shared pointer system when I realized that sometimes Windows would die and I wasn't, or modules in Windows would die and I wouldn't be tracking that. And so we end up in this state where now my game is in a constant fear, or me, the programmer, is in a constant fear. Is this, like, pointer even alive anymore? No good way to really check for that. And sometimes it's possible to design around that, but when you have such a complex system, in my opinion, sometimes you need a convenient method. And I think that's what shared pointers really are, is when you have a lot of complex systems and your design is very hard to understand, you reach this point where you're like, okay, it's easier to layer a shared pointer on top of the system where I don't have to officially keep track of this pointer anymore because it could unpredictably die. I'm going to let the computer do it for me so I can focus on making more stuff. Sometimes that's worth it, even if you lose some performance. And again, you need to make sure, like my rule of thumb, if I ever use shared pointer, is I'm using it like an owning pointer, which is what a unique pointer is for, of course, but it comes with the ref tracking, ref counts. So because of that, it's a little more useful than a weak pointer or a unique pointer. You just have to be really careful. Once 2 or more containers own a shared pointer, that's where you screw up and everything messes up. So that's the situation we always avoid. And I try my best to define and keep them in those containers specifically. Ooh, looks like all these have true flags here. So I need to go in here and... Okay, that one's for the whole media. I'm a little confused because we have like multiple things going on in here. So this needs to end... Let me see. Oh, I see. Whether it's in the background or not is based on this condition. So this true is the part of the meteor, and then that's the Boolean. So that, yeah, that just looks a little confusing because I'm like, I'm expecting a true or false here. Okay, oh, I just made this big. Okay. Yeah. And I just get to ramble a little bit since this is all just tedious work right now. But it gives me a chance to just chat about, like, programming concepts and stuff. So that's always fun. Hi there, Eddie. Welcome. Currently doing the refactorings, which admittedly is just doing the same thing over and over to a bunch of places in my code. But yeah. Hopefully your Thursday is going well. We're just taking time. Oh, I did that to add event. I thought it was add effect. Oops. Go back, please. Only do it to this one. Yeah, I was just talking about how, like, our choices to refactor, there's a lot to think about. And the biggest cost is time, so we have to really make a very, I guess, informed and thorough decision when deciding to do these refactors. I think I messed this up. Let me see. How did this work? I'm a little confused. This is the back flag? I think so. I think it's supposed to look like this. Yeah, that looks right to me. Okay. Some of these are a little more confusing because they just have a bunch of extra stuff in them. And then back here, we call add effect, like so. Boom. No. Do that. Okay, that one has a true flag, so I need to do that separately. Okay, that one's already done. I'm not seeing this one. Oh, I see it. Yeah, IntelliSense is having a field day right now, so a lot of syntax highlighting is currently missing. So this is a fun adventure to wade through a bunch of code. All right. We're like halfway through the list now. So after this refactor, the expectation is that we're going to have a nicer way to handle these because now they're in weak pointers, so we can do whatever we want afterwards and we'll know if they're still alive or not, so that's nice. Also, I didn't know you could click on these from here. I don't think I've ever tried, but that's actually really convenient. I don't know if that's new or not. I've never tried doing this. This must be new. But that is super helpful. You can click on these and it goes right to it. That's really cool, actually. It even highlights it. Oh wait, no, that's from the selector, but yeah. Okay, that's kind of cool. I'll give Insider +1 for that. We're trying to find the goods and bads of using the current Insider version of Visual Studio as we go. I'm just keeping mental notes. Because we've had some good and some bad. Because essentially it's an insider version, which means it's not like... it's not completely like perfect yet, like ready for prod. So we do get some weird stuff happening on occasion. It's interesting to keep an eye on all that as we go along. I don't know what this parenthesis is for. It looks out of place for sure. I must be missing something though, because this isn't working out, or maybe it is, and it's just IntelliSense being slow again. I think this is correct. Oh wait, this is okay, this is the double up version. I see now. So yeah, this argument ends here, second argument begins here. Okay, we haven't seen this so far, so that's good to know. I'm like, surely IntelliSense at least could calculate that much on the fly. Alright. We got a bunch here. And we got a background effect, so that's going to be separate. I really think hold on. I keep getting confused. Okay, the add effect is, you put this outside because wait, no, that doesn't work. This parenthesis needs to get deleted. Okay, I'm gonna have a bunch of syntax errors because I keep missing that. But yes, when we do this, there's a lingering parenthesis on the other side, and I'm missing that a couple times, so I need to fix that. The other one looks like it has a lambda in it, so that's fun. But yeah, that parenthesis needs to get exchanged for a curly brace instead. It's got a fun little lambda function in there too. But yes, there's probably gonna be some syntax errors I have to back up on because I kind of messed that up in a couple places. Forgetting, it's replaced. The parenthesis is replaced with a curly brace. It would be right there. So yes, that's fine. Compiler will tell us. Compiler will yell at us in a little bit. I'm not worried. I don't know how I opened the Task Runner Explorer though. That's fun. Okay. So far so good. I really don't want to stay in this window if I can avoid it, please. Move this over here. Ideally, I would like to stay out here for now. Okay. So we got a couple more here, I presume. Spawn pillar boss. The pillar spawning boss. Yeah. I guess the fun thing about refactoring is you get to look at a bunch of code from the game. You just get to exposed to a lot of code very quickly. So it's kind of fun to just glance at all the code as we go along. Like, I'm looking at it, I'm like, oh yeah, I remember writing this, or I remember debugging this mess, like that kind of thing. Not that it's a mess, but more like it's, right? Just in the moments where you're working on it, you remember like, oh god, that was painful to implement, or I was debugging that for hours trying to remember how things worked, like blah blah blah. That should be correct. Yes. Spell circle. So yeah, you just get to see a lot of code. It's kind of fun to just revisit old code. In passing, this project has, I think I recently hit 46,000 lines of self-written code. And by that I mean there's plenty more, but it's all from like libraries and stuff, so yeah, I'm just curious real quick. I have a little thing that checks for non-commented hi there, Ethokia, welcome. That shows us the code we've written in terms of like lines, because it's always just a fun little stat. It's kind of meaningless, but it's also kind of just fun. I think it's that? Yeah, so we're up to, so this is like, if we count every single line of code in my project, but not necessarily ones I've written, and then this is where we are at with just the files I have. So yeah, we're up to like 47,000. Now, the largest code base I've written prior to this game was a Minecraft plugin, so which had about 42,000 lines, so it's kind of cool to finally see the complexity of this game reach a level that surpasses that. What's that beautiful IDE? Yeah, it's Visual Studio styled with an extension called Claudia IDE, where you can like set up like where you want to open like images and stuff. So like you can have a little slideshow go and you can change the transparency and the coloring. It's great. Yeah. And other than that, I tend to remove all the extra junk toolbars so I can just see as much code as possible, right? I like my screen real estate. That's also why I have 3 ultra wide monitors all around me. Yeah, like literally, I essentially have 6 screens, which is kind of nice for programming. I can see so much at once. Sometimes that's very handy. I also like to code very horizontally, so sometimes it's fun to try to put like an entire line on one screen. Yeah. It's kind of cool looking too. When my girlfriend first saw it, she was like, "Oh my god." That's insane. Just to see it in like a circle of monitors around you. Half circle of monitors. It's kind of always been like a pipe dream of mine, and then I saw like I had an opportunity to get some of these, so I did. So that was cool. Alright, so let's see what's going on here. This one's a little tricky because we're only supposed to accept our values for a game add effect. So this is going to be interesting because we defined this as a thrown projectile explode effect. Hi there, CJ. Welcome. Good to see you. Oh yeah, by the way, I tried to add you on retro achievements and there's just no button to do that. Do you know how that works? Do I have to actually like start playing or something? I might have to do that first. Like, I don't think it... Like, I couldn't find anything to add you. Oh, I think this is just bad code. Hold on. 1, 2, okay. Yeah, like there... So, when I was looking it up, I'm like, everybody's like, yeah, just click the follow button. I'm like, what follow button? There's no follow button. I promise, I looked, I'm not being dumb. I'm human. Alright. So this is your page. Let me sign in. Right? It is A-A-M-A-Y. So yeah, I look here. Like, I would expect it up here. This is like where I was told to click. And I'm like, there's message and there's block. And that's it. Let me type it real quick in case. A-A-M-A-Y. Here we go. Weird, I just followed you. Yeah, I don't have a button for that. Like, I don't see anything. Okay. Yeah, it says, you're not following anyone yet. Why not join us on Discord and find someone to follow? And I'm like, well, I don't necessarily want to do that, so... I would expect on your page I can, like, click something, so... It's just kind of weird. Just... thought I'd mention that, but... Yeah, I'll try to play some games and get some achievements eventually. It'll be fun. Okay, yeah, maybe it's like, it prevents like bots or something, maybe. Like, you can't add people if you don't have enough reputation, just to prevent spam and stuff. I could definitely see something like that. Okay, so this is no longer an effect reference. This is now a standard weak pointer. And so, we'll just adjust that real quick. Weak pointer effect. And now that I have that, we just lock it and we can access the position and change it. Same with this lingering effect. It looks like we dynamic cast it, which is kind of weird. Why are we doing that? I guess... Oh, because these are just the base class. That makes sense. So we're changing it to this, and then get rid of all those fun things. And then we end up dynamic casting. Do I still dynamic cast the weak pointer? No, I dynamic pointer cast. Dynamic pointer cast to lingering effect. Standard weak pointer, standard shared pointer. Hold on. Oh god, it's been a minute. It's not dynamic pointer cast. Trying to think here. Anyway, let's see here. If you need getting everything down on with saying and stuff, let me know. Yeah, for sure. I've just been very much in the grind for this game, so I really haven't had the time to sit down and like play games. Also, Plasticky and I have been playing a lot of Pocopia. Oh my god, that's so fun. Hi Amy and chat. I just discovered JavaX9 on YouTube. Yeah, that's the guy that made the OLC Pixel game engine, which is what my game runs on. Yeah. And that's the community I kind of got involved in. That started my whole C++ journey, so... Yep, that is that guy. Yeah, it's just a nice refreshing take on, like, I guess a Pokemon game. It's like Pokemon Animal Crossing Minecraft is the best way to describe it. But it's pretty fun. I enjoyed it. Okay, and then this wants to be one of these. So I don't know. Is it not dynamic pointer cast? Let me look in component, because I know for components, which is our menu system, we had to do this. So let me just look in here real quick and we'll see what's going on, or try to discover what's going on. Usually we have like an add component function. Let me see. I need to find that function. So let's try and see here. Add component. Let's look in members across the entire... Here we go. So in here, we end up getting a shared pointer T out of it, and it's supposed to, like, I think... Dynamic pointer? Here we go. Oh, it's in caps? No, I think I made this, but I made it for a good reason. It's like, it has error handling. That's why. So let me look at that real quick. Okay, same thing. Oh, here we go. Okay, so I made a function called, a templated function called dynamic pointer cast, all caps, which does call dynamic pointer cast. Oh, okay, you're not supposed to include the weak pointer part of it. But then it has error handling, so if it doesn't work, it... Let me see why that we do that. If not new... Okay, so dynamic casting returns false if it didn't work. But it's silent, as far as I remember. So you could try dynamic casting and it doesn't work, and then you would end up dealing with its side effects. So basically wrote a wrapper that crashes the game if we fail to convert. So basically we're making sure that converts correctly. And it's supposed to just be this. Like, that would be the correct syntax. So I think... like, compilers should be happy about that, in theory. Or maybe this only returns as a shared pointer? But then again, if we're getting a weak pointer out of this, that's not the shared pointer. The shared pointer is if we lock this value afterward. So we probably have to do... Well, I'm missing a parenthesis for one. But yeah, I think we can't do this... Oh. Am I missing another one? Yeah, I'm missing another parenthesis for the dynamic pointer cast. And then, again, I don't believe we can do that for a weak pointer. Like, it would be... Yeah, it would have to be a shared pointer. So I would have to lock it here, and then get the shared pointer out of it, then dynamic pointer cast it, put it out here, modify it. And it's a shared pointer that has a limited lifetime. So that's the thing I was talking about, right? As long as we're not inserting this into a container, we're not in trouble. The moment something else owns this shared pointer, we are in trouble. I think technically I can implicitly get a weak pointer out of this. That's actually safer, but for dynamic pointer cast, it requires the shared pointer. So we do have to lock the weak pointer here, which is fair. And then down here, I would do more locks. And it might seem redundant to do that when up here we had a shared pointer anyways, but this is more for safety. Like, I'd rather it stay a weak pointer than accidentally try and store that shared pointer somewhere I shouldn't, right? That would suck. That would not be great. Also, I'm totally messing those up. So that's how we would do that. I am going to use the dynamic pointer cast with error handling that I made. That is safer. And that takes care of that one. Alright. Back to this. So the rest of these should be pretty simple. It's just every once in a while we end up with like a special case that doesn't quite work with everything else. So yeah. Are you interested in working with the OLC Pixel game engine, Tiger? Because if you are, I'm very excited. I would love to see another fellow OLC user on board. I like your safety first approach, defensive programming. Yes, it's for defending against myself. Exactly. I mean, it's the whole reason we're even doing this refactor is, it's to add even more safeguards. It was returning a reference before, and the reference was for an item in a vector. That's not going to remain. That's going to go stale when I add too many things to it, so there's no guarantee that reference would have been good down the line. So just a lot of design decisions to kind of, I guess, determine that this refactor is a requirement. Because obviously I'm not sitting here for fun just deciding, yeah, I'm just gonna change out my code one day. Like it's all got a purpose, right? I normally do math and puzzle solving with just numeric outputs, but I often wish I could make visualizations. Oh, yeah. And especially for something like this is very simple. You just get a screen, you just get a window to draw on, you just put this header in, and it just works. That's the beauty of it, right? So when you are visualizing things, this kind of framework is super perfect for that. You can just get something on screen and then your data is visualized. I actually was thinking about visualizing like a list of IP addresses and trying to figure out if I can make some correlations with that, like, but seeing it visually. Because I have here my get t blocker. I think I've mentioned it before, and it just constantly scans my get t access logs and removes any IPs that access things that are essentially only accessed by bots. Like, no normal human would ever want to look at those things. So I have all these IPs now, and I want to, like, I think what I want to do is write an algorithm that says if there's a certain percentage of IPs within a subnet and it matches, I just want to ban the entire subnet range, because supposedly this pool is all from, like, let's say an AWS instance or something, right? So, yeah. I did a basic OpenGL course years ago, but that was the last time I touched graphics. I see, yeah. So having some little framework on top that just abstracts the drawing bit out so you can draw images and pixels on screen is super nice. So yeah, like you can even see right now, we have a couple of IPs here that just got banned. So at some point I want to sit down and take all these 50-something thousand IPs and constantly expanding to just figure out, like, can I just get a couple subnets in here and then we're good? We don't have to keep banning, like, IP after IP. That would be nice. It's just a fun little problem that maybe I can do one day on the side. Little fun project. But like visualizing all the IP addresses in like a small map would be kind of fun. I think I've seen a video of somebody doing something similar in terms of using or making like a graphic of IPs. I'm trying to remember what it was about. It was a pretty fascinating topic. Oh, it was the video about hard drives and using ping or ICMP as data storage, which was rather fascinating. I love that. It's like the most nerdiest thing you could do. It's like, oh, I'm just gonna ping the internet and use it as a hard drive. Absolutely hilarious. Sounds great. Right now I have a few hundred vectors which contain just like 4 different colors for pixels and some squares. Oh, okay, yeah, that'd be fun. People have crazy creative ideas. I know, right? Gotta love it. Have I ever introduced you to that video, The Art of Code by Dylan Beatty, I believe? That video is an amazing watch. Just in general, I absolutely loved that. Yeah, for sure. It's just a nice little talk at oh, I can't even remember it anymore. But just a nice little talk over that kind of stuff. Let me see. Just to make sure I'm thinking of the right thing and I'm not just giving you something random. Yeah, The Art of Code by Dylan Beatty. Oh, NDC, that's what it was. Cool, yeah. He's done this a couple times, but the talk mostly stays the same, so naturally you can just use that, but fantastic little talk. I love that. Just one of my favorites that I love viewing every once in a while. And like, if somebody needs like motivation for like programming or like wants to know like what programming is about, I usually direct them to that one, because even if you have no computer or programming background, that talk is very much like a seller for like just software and computer programming as a whole. Somehow I messed this up. What is going on here? The add effect needs to, so this needs to be add effect, there's the true, that's just connected to something else. What is that connected to? Oh, that's the lambda. So that was the lambda. I need to add, so yeah, it should be this next. And then add effect closes, and then effect... Oh, this isn't an effect reference anymore, it's a weak pointer. Why do we need this, though? I don't think we need this. Like, I think my intent originally was to use it for something, and then I didn't, so... Yeah. Just kind of random how that turned out. Ooh, that doesn't look good. I think my preference when I multi-line a function is to keep the curly braces. I haven't encountered that before, but yeah, I don't want to single line that. That looks confusing. Let's see here. Like, it's kind of cool to see as I go along and, like, code more the preferences I have when it comes to formatting. Because I manually format everything I write, so... when there's a new weird situation, I kind of have to evaluate and be like, okay, what kind of formatting style do I like best with it? And sometimes the formatting style changes, so I go back on older code and I'm like, that looks weird. I don't code like that anymore. I've been watching a bunch of CPPCon, which go over my head, but still learn a lot too. Oh, nice. I finally figured out the standard ranges and view stuff after watching a CPPCon vid myself. I figured I would while getting ready one day. But yeah. I found out the key was basically using standard ranges too, which is very powerful and pretty much required to interface back from a view to a range, which then is essentially a vector. So that was the key that I was missing in like pretty much all my attempts at using it. Your code style is nice. You don't put spaces everywhere like I do. Fit more in view your way. Yeah. That does have some cons though, especially for folks that are not used to it. It can get very... I feel like the syntax highlighting really carries it. If it wasn't syntax highlighting, I think this would be very, very rough to read. And like we can kind of see that if I pull up a raw file, right? Like once you don't have the syntax highlighting, and I mean that's just in general, even with code that is well formatted. Once the syntax highlighting is gone, it does get a lot harder to read. So that is the downside. But with all the coloring, it really blocks everything out, so it looks better. But I don't think it holds up as well without the coloring. Yeah. But like this, it looks beautiful, and it saves space, so I like it a lot. Plus, I just find it a waste of energy, as silly as it is. We're just moving our thumb, right? To keep tapping the spacebar a million times. Poor spacebar gets no love. Alright, so I've modified every add effect. I'm going to recompile, and we're just going to keep cleaning up. We're in the middle of a big refactor, so... whatever mistakes I made or changes I've made, we need to see what happens. Ooh. I get packaged today too? Man, I'm getting spoiled. Hold on, is it here? Is it just like... hold on, let me go check outside real quick. Alright, cool. I'm excited. So I'm currently playing Pokopia with my girlfriend. And so, if you pre-order it, at least through Best Buy, you get a cute little bag. Look at the bag. It's so cute. It's got the little ditto, and it's got... okay, there we go. We can see a little berry there. It has a squirrel and the Charmander and Bulbasaur and a Lepa berry. Cute. Yeah. Okay, what are we dealing with now? Let's see. Cannot convert from initializer root list to foreground and background wrapper. Why not? Because these are these return weak pointers, right? Weak pointer effect, okay. So it returns a pair of these two. No instance matches the argument list. Argument types are effect. Oh. Oh, I see what we did here. It turned into an L value from an R value? Wait, what do I do with this? Do I just copy it again? Is that really required? Wait, can I move it? Can I move an R value? I might try doing that, because this is valid. We could just copy it. I feel like that's a waste, though. Why do we have to copy the same data again? That's kind of dumb. Let me try a standard move. I don't know how that will work in for an R value. Oh. That might work. Because for an R value, you're never going to be able to use it outside of passing it in the function. So if we move it, we're not losing anything from this. We're just passing it around. Okay, good. Actually, now that I think about it, that's... standard move makes so much more sense now. I was told standard move is literally just turning things into an R value. Now I get it. I just used it correctly. Okay, so I've been like, somebody told me one time standard move is used to turn into an R value. I'm like, well, what's the point of that? Why would I do that, right? Like, it doesn't move anything, it just turns it into an R value, which effectively is the same thing. You're just passing it in to someplace else, and it's never going to be used here again. So it essentially becomes what's called a move, but internally, that's what an R value is. I just had a revelation, so that's cool. Okay, so that makes sense. Because I've always thought about that, like, yeah, it's called standard move, so you think, oh, it's being moved to another place, but somebody once told me that it turns it into an R value, and ever since then, I've been so confused. Now I get it. Oh my god. It all makes sense now. Now that I've never really had a use for R value before, but in this case, it's actually perfect for it. So I'm finding that fascinating, that the knowledge of, it's like when you're first like using something, you have no clue why you're doing it, right? You're just doing it because you were told to, and then now that we're actually applying it to a real scenario, I finally get to use it and I see what it's actually doing. Okay, so one of the changes we made, or part of this refactor, is this argument is being changed from being a pointer directly to being an effect. But it's not just being, so it used to be an effect pointer, but then I'm like, I'm just moving the pointer into a vector. Why do I do it that way? So instead, I'm just creating the effect directly and then making a pointer out of it by passing it into here. But then I realized that I can make this an R value. And what an R value is, it's only allowed to be on the right-hand side, right? That's why it's called R val in the first place. So let's say we had a... where's my lightning orb? I was showing it there, so I'll go back. Lightning orb. Lightning... Where is my lightning orb? Okay, let's just go in here. Okay, so I was showing in here earlier. Let me undo this real quick. So let's say you make a new effect, and before you were allowed to do this, you can make a new effect outside of here, right? So this will make a new instance of the effect, whatever arguments it has. Then you pass it along in here, like the new version of the argument list would have accepted that effect. And typically this is okay, right? You're like, this function would like cause it to be added to a list. But now, since it's added to a list as a new pointer, what is owning that memory? It's this container. It makes a new share pointer out of that object. So because of that, what if I start doing something like new effect dot color is blue? I just changed the color, right? I'm not going to see this in game because I'm modifying this object, not the object in the container. Like add effect is supposed to return the object that gets added to the container. Now, because of that, really what we should be doing is passing the parameters into here, like by making a new effect that way, right? And then the result should be new effect equals whatever, and then modifying it that way. That's the way we want it to be used. But in one way you can do that in C++ is with an R value. This is now on the right-hand side and only the right-hand side. It can't be on the left-hand side like this, where this is essentially an assignment, right? This is the same thing as doing this. So it's just a shortcut. But this is assigning it to here, which is on the left-hand side, an L val. So we can use this concept of an R val to say, I only want to accept an R val as a parameter. We can't accept an L val, which is what new effect is. So by putting two ampersands next to each other, you're saying I only want an R val parameter. And now the compiler will make sure you can only do that. Like if we try to do this, again, I can just... If I try to do this and pass in this, this actually now is a compiler error because there's no instance of overload function that accepts an effect. as opposed to like what you might typically see, which is just a reference, right? Just one ampersand. So the double ampersand is not to be confused as like a reference of a reference. So that was like the biggest thing for me when I was first learning it. You just have to associate that two of these means it's an arval. Yeah, so we're using it as a restrictor, but that's actually exactly, this is like an exact use case of this thing. You don't want the memory to be managed by some outer scope. So you only pass the instance and it handles the rest. And then we can think about standard move now. So standard move is supposed to take all the data from one location, memory location, and insert it somewhere else. In this case, it's only passing it to here. So it's still an R value, which is why when somebody told me standard move makes things an R value, I got really confused. I'm like, well, what's the point of that? Doesn't it move memory, right? But if it's turned into an R value, that's essentially what you're doing, saying this data is now in here instead. It's been moved. So I finally connected the dots. Rval, standard move, only provide instances within the scope of this function. It's kind of wild, but it actually has a use case here to prevent bad code. And so when I realized this, I'm like, okay, now I really get it. Now that I've had to use it in a more practical purpose, I understand now. It all makes sense. So kind of have these revelations, which are really awesome to have. So yeah, let me try to fix this real quick. Yeah. Oh yeah, for sure. Like, this is a very weird... This is the first time I'm actually using rvals for my own, like, purposes. Usually you see rvals included in, like, copy constructors, right? And in that sense, it makes sense why they do that. It uses what's called return value optimization, which if you don't standard move your stuff yourself, the compiler might be able to do it for you. So that's called RVO. C++ is just insane when you get down to it. And this is probably some of the stuff you might have heard thrown around when it comes to like CPPCon talks. They will talk a lot about this stuff too. And so it gets really hard to follow when you have no context. Yeah. And trying to remember all these terms, hear all these things, like C++ does so much for you. It's insane. That's why it's such a hard language to learn. It's not just learning the syntax, but learning all the intricacies of the behaviors of the language. There's a lot of hidden stuff that C++ doesn't do. When you're first starting out, like, you're harmlessly copying, or you're harmfully copying variables and you don't realize it because you have no clue about the ampersand, the reference symbol, right? So you're just like, oh, I'm making this equal to that. In Java, that would be a copy on a non-primitive object. You know, in Python just handles it all for you. So does JavaScript, right? But here, you just make copies of data types and you don't even realize it, and these become expensive really fast. And then you're wondering why your performance sucks. And then you start learning about all sorts of things. You start learning about const, you start learning about enum classes and templates, and then return value optimization, and the most vexing parse, you learn about virtual. Like, you just start going down this rabbit hole of like everything. You learn about vtables. You learn about standard any, standard optional, standard, the one I learned recently was, standard expected? Yeah. Standard expected, which is like the opposite of a standard optional, where it provides a way to represent either of two values. It's the expected value or an unexpected value, which is like, I'm like, whoa. Yeah, so it has to exist, it has to be some type, and if it doesn't, then it's another type. And it's like, okay. I think it's best used for error handling, but I haven't found it unneeded for it yet. Oh yeah, 23. That's new in C++ land for sure. And I've also recently learned about spans and flat maps and flat sets. Apparently flat maps are basically what the C++ community has wanted instead of just a standard unordered map and standard map, because that's actually constant time. Like, I didn't realize, and I think a lot of people gloss over this when they're first trying to use it, is that unordered map is not constant time. It's, I think, log of n. And the reason is because I think it's a black-red tree or something is like the implementation of it. Let me see real quick if I can find the... There's insert, but let me look at operator, or at. So yeah, the complexity is average case constant, worst case is linear. I guess average case is constant, but like, when you think about these things, it's like, oh, what I really thought I was using this whole time was a flat map. Okay, we're doing that again. Thanks, Firefox? Is this Firefox? I saw Firefox, the logo. Oh, it's because Midori under the hood is Firefox. Anyway, has the functionality of an associative container that contains key value pairs. I think I don't understand the specifics of it. Complexity is logarithmic in the size of the container plus the cost of insertion of an empty element. Logarithmic versus linear in worst case. So I don't know, it's kind of interesting. Actually, I thought it was constant, but apparently it's not. So I think I have more research to do for that, but this is new too. Like, I want to kind of learn this next and see if it has any useful uses on my end, because this is brand new to me. There's just so much to learn, right? So much to work on. And apparently it's C++ 23 as well, so... yeah. Also, apparently there's like an 800-page book or something on templates. I kind of want to buy that. I would love a book specifically on how to do metaprogramming, because I think that is one of my weakest points and something I'm really missing out on that C++ provides, is the ability to do metaprogramming. Yeah, definitely need to check that out and see its use cases. When it's good, when it's bad, right? That's the big thing. Alright, so I'm in the middle of fixing errors. Let's see what else we got. Since I had... we fixed this because we did a standard move there, so that should compile now. Let me just rebuild real quick and make sure that's the case. We'll see what else it complains about. Still got a good 30 minutes for today's coding, so we'll go there. Algorithm. Okay, let's take a look. Cannot convert from const standard share pointer to const standard unique pointer. Okay, somehow we have the arguments wrong because we probably didn't change it, right? Yeah, get background effects. That no longer produces unique pointers, so we gotta change that. Now this is interesting. We get a vector of all the effect pointers. Why would we do that? Where does this get used? Why are we using this? Get all effects. Okay, I mean, that's fair. And we're using a lot of, like, standard copies. We're doing a lot of copies and stuff. This is definitely something we can replace with our new views and ranges knowledge. But also, I think we could just... I want to know where we use this, because we might be able to just get rid of it altogether. Okay, so... I'm seeing one here, which is get effect. Okay. And then I see the declaration, and then in what appears to be a unit test, that's where we use it. Oh, okay, that's interesting. We're using it in unit tests. Fascinating. I mean, I'll keep it for now. It's being used for something, just... let's fix it up a little bit. So let's turn this into a filtered range now. So this is supposed to be for each. It's supposed to put into a vector and output it. Why are we not just returning... Like, my thing is, why are we not just returning a reference to the vector, right? That's confusing to me. I don't understand why I don't just return the vector. It's literally gonna contain the data we need, or want. Standard, shared pointer, I mean, I guess the one thing I would want to do is make it const, maybe? I think I need to make it const. I don't think we want to be modifying it, but yeah, returning a reference to this should be no problem. I don't see why I don't do that. That's confusing to me. Already pretty fast, yeah. Just seems very unnecessary for some reason. I just don't understand what my objective was here. I mean, if I'm returning the pointers, maybe it was to prepare for the eventuality that a vector would be reallocated. So if it's a pointer to the effect, then... No, that still doesn't make sense. Because before, they were all owned by this container, so when the container gets resized, all the pointers are invalidated. So I just don't understand what I was trying to do here. But let's see, let's just put all these together and see what happens, right? So for this, I need to add these two together. We could just do a standard ranges copy here, that should be fine. Or there might even be another function that we could use. Like, there might be like a combine or something. Let's see if we can make that happen. Standard ranges. So we'll be looking again in algorithm for something like that, probably. So ranges all of. No. Ranges for each. I mean, it would be like... fold, left folds. We don't want to fold. Copies a range of elements to a new location. Move, swap ranges. Transform, replace fill. Remove, order changing, sampling. Transformation, swap, copy. I feel like it would be a copy thing. It's like, do we have to have... There's gotta be a way to combine everything, right? Set operations merge. Merge. Oh, there we go. Merges two sorted ranges. Too easy. Alright. So, standard ranges merge. Range 1, range 2, and output. What does output have to be? I guess output would be... result. The beginning of the output range. So we do need a range to output to. Like, it has to exist somehow. Can we just get it as a view? Would a view have that capability? Because that's really what I want. I want a view, and then I want to turn it back into a range. That would be better than making a brand new... Well, I guess that would be the same thing. I'm just trying to be as concise as possible and less verbose, and just make use of my new knowledge. So if we can, like, view merge, that would be great. There's concat. Concatenation of the adapted views. That might be what I want. Takes an arbitrary number of ranges as an argument list. And provides a view that starts at the first element of the first range, ends at the last element of the last range. Beautiful. Okay, so... we would do foreground effects, or rather, we would do... So it would start with the range, and then... Hold on. We get another range with it? Let me see. It would be like... Yeah, just standard views concat. Standard views concat. Now that I understand more of the how to use these, I feel a lot more in control of like managing the data using these functions. So that's super nice, and I'm glad I really started to understand these watching a video about them. It's defined in header ranges, so I'm not sure why it's complaining, but it should be foreground and background effects. Or in this case, it should be get. We're using the getters for these, which is fine. And then we would do standard ranges 2, and we're outputting a vector. So that's what we should be doing in theory. And this would return a vector of standard shared pointer effects. So views has no member concat. Even though it's right here? Oh, it's standard ranges views. I always forget the ranges, or I forget it often. Okay. No, it's still complaining, right? Because, no, standard views is an alias for ranges. We can even see that here. It does show up that way. So that's not it. Let's see here. I feel like that should be all we have to really do. Standard views concat. Am I just missing an include? It says it's in ranges, so ranges should be all I have to do. This was introduced. Oh. Wait, this is 26. Oh shoot, this is very brand new. Hold on. And we're on latest, so it's not even implemented. This is C++ 26. I am on latest, so this is the farthest we can go right now. And it's probably not a good idea to use 26 code anyways, because C++ 26 is probably in very early adoption anyway. Hi there, Mir. So I'm currently working on refactoring this effect function. Essentially, we took those containers and we changed them from holding unique pointers to shared pointers. Because of that modification, we have to go back and change all code that referenced it or assumed we were using unique pointers before. Now we're using shared pointers. So today's like a refactor day. Unfortunately, standard views concat is C++ 26, so we are going to have to hold at least one temporary vector out of here, which is fine. I'm totally okay with that. So it's going to be final out or all effects. And all effects is going to be the combination of these. So again, we'll go back to using standard ranges. What is it? Standard ranges. Hey there, Sour. Welcome. Good to see you again. So we'll go back to using standard ranges merge. We're kind of forced to in this situation. And that should be all we have to really do. And we putting them all in all effects. Like so. Let's see if anything else is missing. No instance of overload function matches argument list. So, okay. We gotta change the declarations of these because they originally are stated as returning effect pointers. They don't do that anymore. Now they return standard shared pointers instead. Like so. And then we look in here. These should be up to date. Oh, they're references. These two are references. The last one we actually constructed from a vector with a brand new vector, so we can't do as a reference. Don't ever return a reference of a temporary inside a function. That's not going to end well, of course. So yeah. We realize that standard views concat is C++26, unavailable to us at this moment. Way too new. Actually, it looks like it doesn't know about merge either. Is that also 26? I'm just looking at these assuming I can use it, but maybe I don't realize some of these things. Okay, this is since 20, so it's a lot more doable, for sure. I would expect it to be implemented. Alright, let's just see what is complaining about. So, argument types are vector, shared pointer, effect, shared pointer effect. And no instance, isn't it range 1, range 2, and output? Range 1, range 2, output. Output should be, oh, it's going to probably be an iterator. So let's provide a back iterator. Back insertion iterator? No? I guess not. Alright, let me read that again. The beginning, oh, the beginning of the output range, okay. Good to know. Are we good now? All effects stop begin. Still doesn't work. Let's see how it's used. Okay, so back inserter would be the same thing. I was on the right track there. Why are we not happy with that? It's essentially the same thing, right? Back inserter. It just doesn't want to work. Maybe this doesn't return what it's supposed to? No conversion. Oh, it returns a merge result. Oh, duh, we have to return the vector. I'm silly. This is just like a standalone function, right? So it's like, it'll just do its thing, and then this is what we return. Okay. I was just overcomplicating it. So that should be good. These are still not... Oh, it's because the vector is const. Whee! Okay. So that's good. I do think the vector wants to be const though. I think with the shared pointer itself, like the pointer is going to store a non-const version of the function of the effect. So making the vector const is important. We don't want the vector to ever get modified. So I think this is correct. We just want to const the vector, because if we want to access the shared pointer non-const, we can, assuming whatever we're accessing it from is a non-const function. Which in this case it is. So we're going to go back to our original error now that started all this. Get background effects located inside of Adventures in Listoria, line 45-47. Oh, we fixed that. Okay. Let me rebuild. And we'll go from there. But it's nice to be able to utilize the power of the ranges and views methods now that we actually know how to manipulate them and we understand the concept of a range and a view and how to get back and forth. So that's really nice. I do wish occasionally standard view, or I do wish standard view concat was already implemented though. I would have liked to use that. Seeing the occasional no discard in there too. Are you trying to take advantage of the new safety features? Oh yeah, for sure. I'm like, hey, I just produced this, especially if it's an expensive function, right? I'm like, hey, I just produced this, you better be using it. Like, if I'm producing the vector inside a function, it better be getting used, or we're gonna have a problem. I'm like, I'm not calling this for fun. I'm not generating the code for fun. There better be a good reason. Yeah. I'm like, you better be using this thing. Alright, let's see what's next. Cannot convert from initializer list to standard... Okay, yeah, so this was using the old version, so we're gonna fix that now. Oh, it looks like we use get all effects in here. That's cool. To do get effect with filtering. So, I think we can also optimize in this sense, right? So we can just return, yeah, we're going to definitely do a view range conversion here. Because yeah, this is a mess, and it's a lot of copies, extra, like, we even have 2 vectors allocated here, and we're populating them all and filtering. It's like, what a mess. So, get all effects, we're gonna pipe it, because it's a range, to a standard views filter view. And the filter is this. These are not effect pointers anymore, they are standard shared pointers. And then from there, we're going to convert back to a range via standard ranges to standard vector. Like so. That should be everything we'll need. I hope. It doesn't like this though. Why not? Is it because of the const? It might be because of the const. I think I remember we can't actually const these. Because this is a vector of share pointer, so it is a range, so doing this is valid in terms of the syntax, so yeah, I think the const is the issue, which is fine. I can just remove it. I kind of put it there with the hope that I wouldn't need to undo it, but looks like that is the case here. And that results in it being good to go. Other than the prototype of the function being wrong now. So that can be fixed in get effect. Right here. Let's just replace it real quick. Okay. So I did find out why you would... I found out the reason why you would sometimes copy instead of do references for small types. And this is a double, so you definitely don't want to reference it. But basically, it's based on the word size of your system. So if the word size is smaller than the total size of whatever you're passing, it's technically more efficient to pass it via value than reference. Or I would say either equal to or faster to pass it by value. So I kind of learned that rule yesterday. So if I have a type like herd type, or okay, that's not a good example. These aren't good examples. Actually, why is it saying 00? That's also not right. I don't know why it's saying that, but that's definitely incorrect. It's probably just IntelliSense being weird, but let's say this is a size of 64 bytes, so because it's 64 bytes, it is larger than the word size, which I guess is 64 bits or 32 bits. I think 64 though. So you would go ahead and pass that by reference if you wanted it to be like efficient. I just learned that the other day. Like, it's kind of cool to see or hear about how like things work on the lower level side, especially if you're working in a systems programming language, which C++ most definitely is, then knowing this stuff is very important. And so for these like lower level programmers, they really understand this stuff so they can really make the most of the performance they have. Like embedded programming, embedded systems design, I think is absolutely fascinating. They have to use every little bit and byte that they have available to them. And the limitations breeds creativity, and the limitations ensures you learn best programming practices. Or maybe not so good programming practices that yield the most bang for your buck. So basic types definitely, because all those will fit in a word, right? So like an int, a float, a double, those are all what? Like max 32 bits, 64 bits, right? So you definitely can fit those in. Like a bool is also 8, I think. I don't know if it tells me. It should tell me, in theory. It's only showing this for custom types, but yeah. Can I actually view like what this does? I've never tried this before. It doesn't look like I can. But yeah, like a boolean is 8 bits. Ints are 16, right? Longs are 32 sometimes, or longs are 32 sometimes, or longs are 60, right? Like it can vary. But the point is, if it's less than your system's architecture word size, then it's more effective to pass by value. There was a CppCon vid by Fedor Pikus about how the CPU pipelining worked, which is so super informative about some of this. Yeah. I feel like I learn a lot from these videos now. I should have, like, I'm pretty sure if I started, like, doing research like this earlier in my programming, I would probably be even more proficient in programming in C++ by now. But everybody learns at their own pace, and I did it as a hobby. I'm still doing it as a hobby, so it's just kind of go at your own pace and learn what you can, right? That's the fun of it. That's what makes it fun. You're learning new information, you're trying to apply it to your projects. It's honestly awesome. Alright, what is it going to yap about next? God, the suspense is killing me. Every time I'm doing refactor, I'm like, are we done yet? No. Are we done now? No. Okay, looks like I missed one. Because this is just probably using the old version of that add effect. Yeah. Probably just missed it. No biggie. Okay. Let's go again when it finishes. You're still going? Okay. I'm like, why are you not scrolling? I have to feel sorry for complete newcomers. It could be off-putting. Really is. It's... There's a video that I think went pretty viral, but also pretty controversial. I don't know if you've seen it. It's like a video saying C++ is like the worst programming language. And it's a bit satire at the same time. If you take it lightly, it's actually a pretty fun video, but if you take it completely to heart as an attack on C++, then yeah, there's a lot of controversy about it. But the one thing I thought was pretty funny was that they mentioned how, which is pretty true, every 3 years there's a new C++ like update, right? So new things being added, and it's just layers and layers and layers, and beginners are starting from the top where they have to learn anything, like they have to learn old C++, essentially like 11 at least. That's like the basics. And then as they add more and more, it's like, okay, you're falling more and more behind, you have to keep up, because everybody that's already at the end who knows C++ 20 and 23, they're moving on to the even more advanced stuff. So you look at C++ 20 versus C++ 11, and you're like, it looks like an entirely different coding language. Yeah, it was just a cool video to see. And definitely was shilling Rust. Let's be for real, right? It was definitely shilling Rust. Alright, so erase if, that's fine. I would like to take a look at Rust now that I have a bigger picture, bigger understanding of C++, right? I understand references more. I understand like what like when you first see mut, I'm like, I don't even understand the concept of mutable. Like, I know that mutable means like you can mutate it, but like, why are we specifying it's mutable when in C++ everything's mutable by default, right? So no, I don't know Rust. I've done Hello World and that's as far as I ever got, so basically don't know anything. But other than looking at a lot of syntax for it, which confused me, and I guess C++ has a couple of ambiguous things, like this double ampersand, right? It doesn't mean a reference of a reference, it means an R vowel. So, yeah, it's like basically new learning curve, new language. And all the memory, like the most fascinating thing about Rust to me, which also is probably the worst thing about it, is the what is it called? It's not called memory checker, it's called something else, right? But that thing makes sure that all your memory exists. The borrow checker, yes, it completely exists within the lifetime of your application as a whole. All the memory you ever create stays within the bounds of any scopes you create all the way from beginning to end. So there is no variable unaccounted for. There's no memory that's allowed to get away until you use unsafe, and then everything gets away. And then you might as well just use C++ anyway. Or C. So I just think it's fascinating. I think it's a very big obstacle. Like, in my opinion, I think it would produce too much friction to make like a game like this. Like, imagine me trying to keep up with something that tells me I have to manage every single data value in this game and how much memory we're passing through. You see there's arguments everywhere, there's variables being created everywhere, right? Having to have all that be managed and follow those rules sounds insane to me. Oh yeah, because double ampersand is logical and, yes. So there's also that. Right. Okay, what are we doing? Why are we here? Standard construct at no overload function found. Oh! It can't construct this shared pointer. It doesn't know what to do. Okay. Oh, right. I have to do standard make shared. Which is fine. I just totally blanked on this. Didn't even think about it. Okay. But then again, we didn't get to template compiling until the very basic stuff would compile, so it makes sense that it took a while to get here. But we're here. Okay. Alright, what's next? What do you got? Cannot convert from unique pointer, okay. I'm surprised I didn't catch that while I was in the file. It's probably just right next to, yeah. Whoa, we do a move? That's crazy. We create that unique pointer. See, this is the exact scenario I wanted to avoid with the new system. I shouldn't be creating... And I bet I made this bug at first. I probably did this before and didn't have the standard move or whatever. So you can actually see I probably circumvented it. I probably tried to do this first, modify it, and then realized I can't do that. So I have to make a unique pointer, modify it before passing it in, and do a move on it. It's like, what a mess to like try and remember and think about. And I also had to actually run the game to realize it was bugged and then make a fix to work around it. It was just disgusting, right? So the fact we're enforcing this now is actually a really good thing. It literally prevents stuff like this from happening. So what we do now is we pass it in as is, get out our explode effect, which is managed by the game. So this is an effect. And then from there, Now we modify it, and it will actually modify it correctly. So that's what we actually want. Cool. Winning. So it's funny that we actually found a place where we tried to circumvent that behavior, which is a bug we created a long time ago. But back then I was very fuzzy on R values. And today was literally the revelation moment, so even up until that point, for the last 2 years or so since I first wrote this code, I've still been clueless, so I think it's very cool to see the progression like that. Alright. What is going on here? We have a dynamic cast. So yeah, it looks like we store it. So this is gonna not be a reference wrapper now. The flame trail is now going to be an optional standard shared pointer, or weak pointer. Does it even have to be optional? Weak pointers technically are invalid until they're given a value, so even the weak pointer by itself could exist like this, and it essentially functions as an optional, so that's kind of cool. Alright, so we have that. Back to the firebolt, which I don't know where that is or where it went. Firebolt. Alright, also it's 4 p.m., so the refactor is taking a little longer than expected. We did talk a lot today. I really enjoy having discussions about stuff, so thank you for that. It's always a pleasure talking to you, Tiger. Just about random stuff. I just love programming too much. I will completely go off the rails to have fun and discuss, right? So we're turning this into a dynamic pointer cast, which is my safer version of dynamic cast, because dynamic cast is silent. And we're turning it into a trail effect. Also, this is... yeah. So this becomes add effect, but this is now a shared pointer created from an instance of trail effect. Okay, going into dynamic pointer cast, into flame trail as a weak pointer. And then whatever uses this weak pointer, we have to lock it now before we can use it. And we also have to see if it exists, so if not expired, then we're allowed to use it by locking it and getting a shared pointer out. So we use pointer syntax there. Oh, this used to be a reference wrapper, so we don't need the value. The value was from the optional, the get was from the wrapper, so we don't need either of those anymore. That's funny. Yeah, no, I just enjoy talking to people about code, and like, we're kind of all learning together, right? It's fun. It's super fun. I love to promote that kind of environment. But yeah, this is a good stopping point. It's fun to see us convert all this code, some using very like strange methods. This refactor is actually cleaning up a lot of that, and we can see it being applied everywhere, so very nice. Also updating things like using a stray dynamic cast, which has no error checking, so I have custom versions of the dynamic casts that actually aren't silent. They will just crash the game if they couldn't, so it's kind of like if you like malloc and you have no idea if the system actually gave you valid memory, you just started using it. It's like the same idea. Yeah. I mean, part of it is because you have, like, Git, right? If you don't have Git, I think you're a lot less confident, so... But there's also the fact of we come up with a plan before we execute and make sure all the reasons we are refactoring seem sound, right? Like, we're not going to run into any more friction. So, it takes me a while. Like, I spent a lot of time yesterday going over, okay, do I really want to run this refactor, right? Trying to figure it out best. But yeah, that's going to be it for today. For those of you that tuned in, thank you for watching. I hope you enjoyed, and we'll see you next time. Bye-bye.